Welcome. In this video we will present the structure of a X2C control block. X2C can be used either with Scilab Xcos or with Matlab-Simulink as a frontend. The X2C blocks in Simulink differ from those in Xcos only by the missing clock input and a different mask. We are using the block named Sin3Gen of this very simple control scheme modeled in Matlab-Simulink. This block generates three 120 degrees shifted sine wave signals at the block outputs U, V, and W. The amplitude of the three signals can be set via input A. The input named F influences the frequency of the generated signals. The structure of a X2C control block is now shown on the right. The green arrow always shows the layer that is currently being spoken about. A double click on the X2C block opens a mask for editing the block parameters. With the help of the conversion function, the parameter values entered in the mask are converted to the values required by the processor. The lowest layer is the C code implementation of the desired functionality of the block, which is executed periodically by the processor. This basic video deals mainly with the layer of the block mask. For more details on the layers of conversion and C code implementation, please see our video, Introducing X2C Block Advanced. Now let's take a look at how such a block is inserted into the model. For this purpose Simulink's library browser has to be opened. Then we browse to the library X2C General and find the X2C Sin3Gen block there. For adding this block, simply select the block in the library and drag and drop it into the model. To change the block name, simply click on the current name and modify it afterwards. The block now only needs to be connected to the other blocks and parameterized. That's it. The functionality is built in. We now delete this block again and use the already integrated one for further explanations. A double click on the block opens the block mask. The block label is found at the top of the mask. Under the block name is a description of the block functionality. This block has three mask parameters. Each mask parameter got one parameter field in which you may enter numerical values and variables. Also, you are free to enter formulas as well as comments. The second parameter, the offset, is not changed in this example. With this parameter an offset shift of the sinusoidal output signals can be set. The third parameter is the sample time multiplier and determines the update frequency of the block. It is an integer value, which is the divisor of the base update frequency of the application. The desired implementation can be set via a drop-down menu. Either fixed point 16 or 32 bits or floating point 32 or 64 bits can be selected. A mixture of various implementations within a model is possible, and the chosen implementation is not restricted by the target's hardware architecture. We choose the 16-bit fixed-point implementation for this block. At the bottom of the mask, advanced settings, like setting a static block ID or enabling conversion on target, can be made. These settings are explained in our video Introducing X2C Block Advanced. There you will also find more information about what happens in the background when parameterizing an X2C block. Now, this simple application is demonstrated. The X2C communicator has already been started and a connection to the LaunchPad from Texas Instruments was established. Also, the X2C scope was started and has been pre-configured already. The three ports, U, V, and W, of block Sin3Gen are scoped. Additionally, the LED output that commands the blue LED is plotted. The sampling process is started by clicking the sample button. Double-clicking the manual switch double frequency doubles the frequencies of the sine waves of ports U, V, and W. Of course, also the blinking frequency of the LED has doubled. Double-clicking the manual switch named double frequency again restores the initial frequency. If you have any more questions or want to have some more information concerning X2C, please have a look at our website x2c.lcm.at and do not hesitate to contact us. Thanks for watching.